Assalamu alaikum wa rahmatullahi wa barakatuh. Minu ya dafo, minu ya ganani. Babi a wobi a utie mi. Misro tu fo Nyankopon se wonye wo kese so ate. Nyankopon dwumadi a wodie bia misro tu fo Nyankopon se onto nsupa ngu so na enye ye mfama. Na ye video a ye ba be we wem se any video etoso enan. Na ya to din science or scientism. We only explain the scientific method. And we want to show that it doesn't answer all questions. We want to show that the scientific method is a very useful method, but it's also got its own limitations. This is the purpose of this video. And once we have been able to establish this, then we can move on to look at other ways of trying to understand reality and truth. So that is our objective today. Now, me person me twa twini si ade bi so. Me person me may observe and picture a very popular and famous picture that we are seeing na nipa bebre nim sa painting ya me beka ho asem. Any the painting be to the Mona Lisa. Na unim painting a friend Mona Lisa, me many how twa twini see any painting or a picture frame. Or it could be your own picture frame that is in a glass in your house. The person who actually sees kakra, the only one come kakra. Say, what you want to call Mona Lisa painting? That's all observe. And if you want to observe this through the scientific method, now we know the scientific method is a method that is used to examine the physical environment around us. And it's only useful for things that are testable, things that are verifiable, experimentable, and some things that are very repeatable. This is where scientific method is very, very useful. Okay? So, using this method, let's look at the Mona Lisa painting. What are the things that we can observe, we can test, we can touch, and we can examine? Maybe you might want to look at maybe the color near the eye. What is the color composition? What is the material composition of the Mona Lisa painting? Maybe you might want to look at the frame and be able to test it. These are the things that we can use science to be able to prove it. Okay? But is that all? Is that all the things that we can observe? These are what science can do with the Mona Lisa painting. But there are other things that is particular with a painting that we cannot use the scientific method to be able to examine. So, for example, an obvious one is the painter. Is the painter. How would you be able to use science to be able to establish the painter as you observe the painting? You wouldn't be able to. But does it mean that because we cannot use a scientific method to establish the painter and his existence at the time, it means there's no painter? How can we have a painting without a painter? In fact, we do know there is a painter of the Mona Lisa painting. And it was made, we know that it was made by Leonardo da Vinci in the beginning of the 16th century. We know who made it. And we know the exact time that he made it. We even know the century that it was made. But we know this for a fact. But we were not able to prove this through the scientific method. focus on the Mona Lisa. Okay? We can also look at it in terms of the photo, painting. No? Na o say me dey every time. When nipa agye won every time. Obi so who say wow. People will say it is very, very exquisite. Beautiful. In fact, there are people who have seen the Mona Lisa painting and they cry. They cry because of its beauty. Yeah? So the point that I'm making here is these ecstatic feelings that we have towards the Mona Lisa painting, these are emotional feelings. The love that we have for it. How do you test this? How do you even examine the love that people have got for the Mona Lisa painting? Where is the love? How do you touch it? How do you see it? Where does the love live? How do you use science to measure the emotions and the feelings that we've got towards the Mona Lisa painting? Science, again, this is beyond the realm of science. So does it mean that we cannot examine this through the scientific method, the emotions that we have towards the Mona Lisa painting? It means those emotions don't exist. Obviously, they exist. Okay? So that is one point that we need to establish. And this leads us to another question of the idea of consciousness. Consciousness. How do you know that I'm a conscious being? How do you know? You haven't examined my brain and the neurons and the electric impulses in my brain to be able to know whether I'm a conscious being or not. So how do you prove consciousness? And many scientists in the past, they know this problem of consciousness. And that's why they say consciousness and how you define it is the hard problem of science. It's so difficult. Think about dreams, for example. Dreams. What could that? No one sundaye. How in a dynamo you are in a different environment? How do you use science to examine the dream? So, looking back to the painting, Mona Lisa painting, and the sort of things that we cannot use a scientific method to examine, like the painter. All right? We wouldn't be able to use the scientific method to prove it. And then the idea of consciousness. This goes to prove there are certain things that the scientific method cannot be used to examine. Let me take you furthermore to other things. We do know certain things 100%, no doubt about that, or near 100% to be fact. But we do know them not through the scientific method. We do know those things to be facts, but we do not know them by using the scientific method. A very good example is if somebody were to ask you this question, that do you believe that you have a great grandfather or grandmother? Ujidi, say oh na 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 na. Yeah. Awuko. Ujidi. Say emre bi atwam. na wo na nkanso bi e wo atwa mu kɔ? The answer is yes. Yes. But we don't examine this truth, which we know to be factual, by the scientific method. So does it mean that we haven't used the scientific method and therefore this is not true? This is true. Now, let's move on to the idea that science can be used to explain everything. And this is where we have a problem. Of course, we know the scientific method is very beautiful. And it has helped human beings to move forward. And we have advanced so much through the scientific method. So this is the truth. We are not saying the scientific method is useless. No! It is a beautiful method. But the idea that it answers all questions and anything that can be proven without the use of the scientific method is a lie. This is where we have a problem with. And our argument here, the discussion here, is that the scientific method, although we believe it's useful, look at what science has made us. Look at the mobile phones, the iPhones. Look at we're able to fly. We're able to be on the sea. All right? Science have helped us so much. But science doesn't answer all questions for us. This is the key point in this video. The science doesn't solve all problems. This must be very clear in our minds. And this is our argument. Now, let's move on from here. And now, let's try and look at the idea that science is a totalist kind of thinking. That everything must be answered through the scientific method. This is called scientism. This is called scientism. The idea that science can be used to answer the totality of all questions, to prove every reality and every knowledge. This is wrong. This is totally wrong, as we have shown. And not only this, science is based on something we call inductiveness or inductive conclusions. And we need to pause and try to make sure we explain this a bit more. What is inductive conclusions? And there's also the opposite of it, which we call the deductive conclusions. In fact, before we explain inductiveness, we try to understand the scientific method itself. What are the steps? And let's cast our mind back to Mrani Eco School, secondary school, yes, be experiment. So be experimenter in the way you report your findings, in the way you report the whole thing, is through 4 stages. The first stage is the aim. The second stage is the method. The third stage is the results. And finally, your conclusions. The aim will tell us, Butaya, what is our research? I want to now state your tentative hypothesis. Something that you think might happen in your research. Here you also need to define your variables. Okay? Then your method. Method is simply what you subject those variables to in order to come out with what you're trying to find out. Okay? This is the method. Now, the results is the data that you get. The data that comes of the whole experimentation. And finally, your conclusions is where you try to link what the results that you have found and try to explain it based on your hypothesis. Does it prove your hypothesis to be correct or it proves it to be wrong? This is the scientific method. All right, this is the scientific method. This is so detailed, and I think I need to water it down a little bit with an example. Let's say, for example, you want to prove the boiling point of water. We all know the boiling point of water. But let's say we didn't know and we want to prove this. Now we will start with your botae and we will state it clearly that your botae say, your perceive show say whether water boils at 100 degrees Celsius. This is our objective. We will then try to explain our method. Or maybe we may say we are going to subject the water, we collect water and subject it to room water, we collect water at room temperature, and then subject it to heat, maybe through the use of Bunsen burner. Okay, heat it, then we will record what we are finding, okay, through a thermometer. And we will repeat this experiment so many times so that we can verify the record that we are having. Based on this, we will make a conclusion. And our conclusion is going to be that based on all the things that we've come out with and our repeated experimentation, we are going to conclude that all water boils at 100 degrees Celsius. You see, this statement of saying, say, ensuo ayediya sijaso ebe huru at 100 degrees Celsius. All of it, every water that we're going to test, this scientific statement that all the water that we can subject to these conditions will boil at 100 degrees Celsius. This is what we call induced conclusion. This is what scientists call inductiveness. It's induced conclusion. So what is inductive conclusion? Let's try and explain it. And I'll try and explain this with an example, a very popular example, which in many books that you come across inductiveness, you will see this example. And that is double, and answer swans. Okay? Now, you might probably say that you want to prove the color of swans. So you go out there where you can find water, whatever, yeah? And you find that the first swan that you see is white. The second is white. And you carry on, and you find 999 swans. So you reach a conclusion that all swans are white. So inductiveness is where you move from the particular to the generalized statement. So you wanted to prove the color of swans. So you started going out there and looking at individual swans, particulars. Then you examine that all the swans that you come across, up to 999 one, they were all white. So you move from the particular to the generalized statement and you conclude that all swans are white. This is what we call inductiveness, from the particular to the generalized. You see, there's a major problem here. There's a major problem, and probably you might have sensed what I'm going to say. What I'm going to say is this. Is this truth? Is this theory that you came up with, is it correct? I don't think it's correct. What if the 1,000th swan that you observe may be black? As soon as you find the 1,000th swan, it destroys your conclusion that you made earlier on. And this is the nature of science. Scientific theories are just like this. They are only true for now. For now, correct. Until new data come around. Yeah? Until we find a new data that prove otherwise. Normally what I say is innocent until proven guilty. Scientific theories are innocent for now. But until new data comes across, we cannot say for sure that they are truth. So that's the point we want to make. So many scientists, in fact empiricists, like Karl Popper, like David Hume, the famous 18th century empiricist, they all knew that scientific statements are inductive statements. So Karl Popper, for example, he argued that to say that water boils at 100 degrees Celsius is wrong. We cannot make such conclusions. We cannot say it is correct for all time to come. But what we can say is that water boils at 100 degrees Celsius until we are able to falsify it. So he came up with the idea of falsification. So he said that the scientific theories are true for now until they are proven to be very false. So he says scientific theories, the only thing that we can say for sure is that they are true until we can falsify them. That's all that we can say. That's all that we can say for now. This leads us into another discussion which is very important. And that is, science is also built on certain axioms. And this is very important. What do I mean by axioms? They are based on certain assumptions. Otherwise, scientific theories are not true. Science must be based on the idea of causality. So what is causality? So for example, let's go back to our boiling point experiment. That when I wanted to find out the boiling point of water, what I did is I collected water, subjected it to some heat, and then observed what was going to happen. Now, what I'm doing here is I'm using the heat to cause the boiling of water. You see, David Hume, what he said was that this kind of assumption is induced. the connection between the cause, the heating of the water and the boiling of water, it is something that is induced. It is my brain that is causing what we are seeing between the independent variable and the dependent variable, i.e. the heating and what we are observing. Let's use another example. David Hume's example was very, very useful one. He was talking about the billiard board, or what today we might call the pool, or the snooker board. Yeah. David Hume, his example was this. He said, let's take on the board, the snooker board, a white ball and a black ball. Okay. When you hit the white ball to go and hit the black ball, there are different possibilities. And let's just assume that we are dealing with somebody who has never seen the snooker board before. And he is trying to observe what is going to happen. Now, when he hits the white ball, there are different possibilities, different outcomes. I bet me see. I bet me say the white ball no hit the black ball no, it can bounce off it. When the white ball no hit it, I bet me say when the white ball hit the black ball no, it can pass through it. I bet me say white ball no hit the black ball no, I bet me disintegrating. Or it can just jump over it to go into the hole or whatever. So there are different possibilities. So let's say you hit the white ball and it goes on to push the black ball and it goes into the hole. What then happens is this. If you are going to repeat the same procedure again, the assumption that you're going to make is that when the white ball hit the black ball, it is going to push it to the hole. You see, you are now making the assumption that it will hit it and it will go into the hole. That is causality. And that is what it's an assumption that you are making. But there are different possibilities. Different possibilities. But you will have assumed that the future event will follow the past event. That's what you are thinking. And this is the basis of science. Science has to assume causality. And that future events will follow past events. Without this, science cannot exist. And as we can see, this is incorrect because the possibilities are many. You see, so this is a very, very, very fundamental point that needs to be clear in your mind. Okay? Now, let's move on. So, what we are saying here, to sum everything up, what we are trying to prove here is science cannot be used to answer all questions, as we have proved. And that although the scientific method is very beautiful and has helped mankind so much, it has got its own limitations. So the idea that science will answer all questions itself, to be honest with you, if you answer it itself, it refutes its own aim. Because if you say science can be used to prove science, that's what we are saying here, then we have a secular problem. which is itself tautology. It doesn't make sense. So the statement, the science, can be used to prove everything. Itself is not a scientific statement because it cannot be proven. In other words, you are using science to prove science, and that's tautology. Secondly, the idea that science answers all questions. So I'm trying to sum everything up. The idea that science answers all questions, and that anything that is answered not through the scientific method is not correct, has been proven to be very false. It's not correct. Secondly, or thirdly, we have also concluded that there are certain facts that we believe to be true. But these facts that we believe almost 100% to be true has not been proven through the scientific method. For example, the example that I gave, that do you believe that you have great grandmother? Of course you do. But did you prove this through the scientific method? No, we didn't. So that doesn't mean that we didn't prove through the scientific method and no, it's correct. It's true that we all have great grandfather or mother. So Imam Ghazali, he sums this up and he says, yes, we can know truth, we can develop knowledge, and we can understand reality through experience. So that's the first thing. So yes, we don't dispute the scientific method. It's a valid method. So Imam Ghazali said, yes, we can use the scientific method or through experience to be able to understand reality and develop knowledge. But that's not the only way. He goes on to say that we could also use oral narrations, historical events. So, for example, I do know that the World War II happened, but I wasn't born then, I wasn't living then, but we know it's a sacred truth that it happened through historical records. So this is not proven by scientific method, but we know it is true. Finally, Imam Ghazali, he said we can also establish truth through something we call synthetic propositions. Yeah, synthetic propositions. What do we mean by synthetic propositions? These are mathematical proofs where we can say that 1,000, for example, is greater than 1. These are mathematical calculations, and we don't need science to test this, but we believe them to be true. So, science doesn't answer all questions. Science is useful, and it can only be used to understand physical reality. There are other things outside science that we can examine through other ways. This leads us perfectly to the next video where we use other methods, we explain other methods to be able to use them to be able to prove the existence of Allah subhanahu wa ta'ala. And that method will be the rational method. So the next video, inshallah, we're going to explain what is the rational method. And we're going to try and see how the rational method could be used to prove the existence of Allah subhanahu wa ta'ala in the videos that will follow. Nankopo, onye okese se wase umre na utie sansem we. Se de be ma wujidi asipi. Na wonso communicate so ye osofo, so ye kramonia, we preacher, se be boa na watimi ama wonsama clear. So we explain things to anybody. Na me onye okese na de wo ye bi enye ye mfama wo ye hwes rahima otumfo Nyankopon oma wonsanka bi. On show den on pedi on ma wonya de opebia wa akhir da'wana anil hamdulillahi rabbil alamin.